Autonomous vehicles are a hot topic in today's tech world, and for the future, they have tons of application in fields such as the military, manufacturing, and, notably, transportation. That is why our team decided to compete with Tesla's full self-driving with an invention of our own. We are Team 22, the self-driven, and this is the Bobot AI. The Bobot AI utilizes a micro camera and ultrasonic sensors to process data from its surrounding environment and pass decisions into the continuous rotational servos so that the robot can maneuver accordingly. Our main goals were to have the Bobot AI maneuver around obstacles, recognize street signs, obey traffic lights, and follow a road. The OpenMV H7 camera is especially crucial because not only does it provide us the live video feed, it is also the microcontroller that runs Python programs processing input data from the sensor and the cameras and outputs the signal to other components such as the rotational servos.
Here we will briefly talk about how the ultrasonic sensors on the bot work. So first, as the bot is approaching an object, it will run a function called detect, where it'll trigger and then echo both ultrasonic sensors, and then in the function itself it'll compare the two distances to allow the bot to determine which side has more space, and therefore which side is better to turn toward in order to avoid the object. From here, it will decide which way it's going to turn and then move forward slightly. And then what we actually have it doing is then turning back toward the object so that it can continue to correct itself. And as it's taking these different steps, then it is able to continue to avoid the object while also maintaining a generally straight line and be able to find its way back to the path it's given.
Here, we are looking at what the camera sees during image processing. One can observe that the Bobot is able to mark areas of interest, particularly the white masking tape and the red traffic light. This is done by thresholding RGB values in the image so that objects of particular colors are marked. Once the robot has detected the green light, the necessary logic instructs the robot to move forward. Once the robot detects a stop sign, the necessary logic is executed and the robot is obedient, coming to a full stop for 5 seconds and then continuing on only afterwards. The detection of the stop sign is actually proof of concept and demonstration of advanced image recognition algorithms. The algorithm we used in particular was a 24-stage Haar cascade algorithm, which is fed tons of images of stop signs and learns on the specific features of it. With this capability, there is high potential for the Bobot AI. Just imagine all of the other signs that could have been implemented with more time. Finally, we need to go over how the robot even begins to follow a line. Splitting the frame into 3 different sections, we've taken an estimate of where the center position is for the mask tape in each different section. Once we calculate the average of all of the center positions of the road, we can use trigonometry to estimate the offset angle between where the road actually is and where the robot is facing. We can feed this offset angle into a PID control system, which should instruct the continuous servos of the robot to move accordingly such that the robot is in line with the road. I would highly encourage you to take a look at the Python code that achieves this because I think it's really cool. And with all that, here is a demonstration of what the robot can do with the OpenMV camera.